Hello, my name is Jeongjin Lee, and I'm a senior at LaGuardia High School. Today, I will present my research titled The Rising Threat of Liver Cancer, a Biochemical Analysis of Acetaldehyde Formation in Alcoholic Beverages. So, this research examines how the chemical properties of common alcoholic beverages can influence the buildup of acetaldehyde, which is a toxic compound that has strong correlation with liver damage and liver cancer. This is the table of contents. We'll first introduction, then we'll go to research question, methods, clinical significance, limitations, conclusions. Introduction. Alcohol-related liver cancer has become a growing concern, especially among older adults in the United States. And as you can see in the graph shows the incidence rate of liver and intrahepatic bile duct cancer by specific age groups. Ages 65 and older, cancer rates have consistently increased over the years, while in contrast, the 55 to 64 age group experienced a steady increase in cancer rates from 2000 until 2015, followed by a decline from 2015 to 2020. One of the most harmful byproducts of drinking alcohol is acetaldehyde, which is formed as the body breaks down ethanol. And acetaldehyde is dangerous to our body because it causes DNA damage, protein cross linking, oxidative stress, and long term cellular injury, which can ultimately contribute to liver fibrosis, cirrhosis, and hepatocellular carcinoma, which is a common type of liver cancer. So, my research focuses on whether certain alcoholic beverages create chemical conditions that increase the likelihood of acetaldehyde buildup. So, why acetaldehyde matters? Ethanol metabolism occurs in major steps. First, ethanol is converted to acetaldehyde by the enzyme alcohol dehydrogenase, or ADH. Secondly, acetaldehyde is converted into acetate by the enzyme aldehyde dehydrogenase, especially by ALDH2. But problems arise when ALDH activity is slowed, inhibited, or overwhelmed. If acetaldehyde accumulates, it becomes toxic. And so, certain conditions like low pH or the presence of fermentation byproducts can interfere with ALDH activity. Additionally, people with hepatocellular carcinoma, hemochromatosis, alpha 1 antitrypsin deficiency, or existing liver disease are at higher risk. So, understanding this disruption in ethanol metabolism is essential because they help explain why different individuals and different conditions lead to very different physiological responses to alcohol. Research question. So, my research question in the study was do different alcoholic beverages, specifically wine, beer, whiskey, soju, and rice wine, differ in their chemical properties in ways that can influence aldehyde buildup? I focus on two measurable, quantifiable properties, um, which was acidity by pH and chemical complexity using chromatography tests. These factors influence how easily acetaldehyde is broken down, and together these two properties gave me a clear framework to compare each beverage and see which ones might create conditions that slow ALDH and lead to higher acetaldehyde buildup. Methods. As I mentioned before, um, I used two core methods. The first method was chromatography test, and this technique separates pigments and chemical components, allowing me to compare number of pigment bands, relative complexity, RF values, and presence of fermentation byproducts. Um, and my second method was pH measurement using pH indicator. I measured the acidity of each beverage, which might influence enzyme activity, especially ALDH. This was the method overview. So, chromatography tests showed clear differences in chemical complexity among the drinks. This was the chromatography test I did, and starting from soju, it had an RF value of 1 with almost no bends, showing very simple, highly soluble molecules. And while whiskey had the lowest RF and almost no pigments because distillation removes most compounds. And wine showed many bends and an RF value of 0.67, meaning it contains diverse polyphenols and acids. And moving on to rice wine, it also had multiple bends and high RF value of 0.89, indicating many small fermentation byproducts. And lastly, beer showed moderate complexity with an RF value of 0.56. Overall, um, wine and rice wine were the most chemically complex, while soju and whiskey were the simplest. So these chromatogram patterns gave me a clear picture of how each beverage's chemical makeup could influence acid aldehyde processing. This was the chromatogram result and basically the over patterns. Um, and moving on to the pH test I did, um, the pH test showed significant differences. Wine had a pH of 4, which was the most acidic. Um, and rice wine had a pH of 5. Beer also had a pH of 5. Whiskey had a pH of 6. And soju had a pH of 8. Wine was the most acidic beverage, while soju is the only beverage that is basic. And since lower pH values reduce ALD's activity, acidic beverages create more favorable conditions for acid aldehyde buildup. So these pH differences help me identify which beverages create conditions that could slow ALDH the most and increase the chance of acid aldehyde buildup. So when we combine these both sets of results, we can see a clear pattern. Um, Starting off with wine, which was very acidic, was pH of 4, and having many pigment bands with mid-range of RF value of 0.67 and contains polyphenols and organic acids. The city slows down the enzymatic activity of ALDH, and the extra molecules can bind to ALDH or change the process of enzymatic activity. So these features can interfere with ALDH, providing the highest potential for acid aldehyde buildup. For rice wine, it is also acidic with pH of 5 and has many pigment bands with a high RF value of 0.89. And this mix shows many small soluble compounds from fermentation present, which can place extra stress on the liver, and this also has a high risk of acid aldehyde buildup. And for beer, it is moderately acidic with pH of 5 and has moderate pigment complexity and moderate PRF of 0.56. This shows that beer still contains fermentation byproducts, but fewer than wine does. And so it is at a moderate risk compared to the wine and rice wine. And moving on to for soju, it has a high alcohol content, which is basic with pH of 8 and has simple chromatogram with RF of 1. This shows that soju has very few extra molecules, and since it's basic, soju does not add extra stress to ALDH activity. So it is at a moderate risk, and the risk comes from the alcohol content, not chemical complexity. And lastly, for whiskey, since it is distilled, it is very pure. Um, it has a moderate pH of 6 and has a very low R value with few bends. The distillation process removes most acids and pigments. The low RF and simple chromatograms show that whiskey contains very few compounds that might slow ALDH. Whiskey has the lowest interference with aldehyde breakdown. So these results show that the type of alcohol affects acid aldehyde buildup. The drinks with more fermentation byproducts and lower pH, like wine and rice wine, place more stress on ALDH. Drinks with simple chemical profiles and moderate pH, like whiskey, place less stress on the enzyme, even if they contain more alcohol. This means both chemical composition and acidity, not just the alcohol percentage, play a major role in liver stress. And moving on to clinical significance, um, individuals with reduced ability to process alcohol, such as hepatocellular carcinoma, alpha 1 antitrypsin deficiency, and hemochromatosis, face higher risk when drinking alcoholic beverages that are specific, contain fermentation byproducts, or inhibit ALDH. This means wine and rice wine may pose disproportionate risks for these individuals, and understanding the differences could help guide more personalized recommendation for these individuals with vulnerable liver conditions. So, recognizing how each beverage's chemistry interacts with ALDH gives us a deeper, more accurate understanding of why some drinks place far greater stress on the liver than others. And limitations. Um, this study has some limitations. I use qualitative analysis rather than direct acid aldehyde measurements. The chromatography technique does not identify specific types of compounds present, and results do not include human or animal testing. And I didn't analyze genetic factors, enzyme kinetics, or in vivo metabolism. And I mean, for future research, I would include like spectrometric analysis, ALDH activity assays, um, genetic analysis of ALDH2 variants, and controlled biological testing. And despite all the limitations, these findings create a foundation for more advanced studies of the risk of alcoholic beverages on the liver. And still, these results provide an early framework for explaining how beverage chemistry affects acid aldehyde levels and point the way toward to deeper and more precise research. Conclusion. Um, so this study shows the role of chemical composition on alcohol-related acid aldehyde risk on the liver, and the key findings are that wine and rice wine create the most concerning biochemical conditions for acid aldehyde buildup, and which whiskey appears least likely to interfere with acid aldehyde detoxification due to its purity, and acidity and fermentation byproducts are more important than alcohol percentage alone when determining the risk of alcoholic beverages on the liver. So these insights may help improve public health recommendations for people with liver vulnerabilities. Thank you for listening.